नमस्कार सर, वीसी साहब को
हेलो सोमशेखर जी।
सर नमस्कार सर, नमस्कार
नमस्कार
नमस्कार सर। थैंक यू वेरी मच सर फॉर joining the webinar sir.
As you directed me, I thought that you may be delaying for the Binay Pathak.
Sir.
But he is coming on
10:30 sir. He will be joining at 10:30 sir.
By that time our inauguration will be over, I think.
No sir, it will be going on. It will be going on, and anytime I will be requesting after my welcome speech sir.
Okay.
Sir.
How is Sis Gupta na sitting with you? No. Your head computer science Gupta na?
Yes sir. Dr. Sachi.
Sachi, yeah, I saw her. Good morning. I saw her in NBA. That she came for presentation. She came for presentation that day. गायब कैसे होता है?
बना दूं? मैं बोल रहा है
कुछ चौथे में आ गया है कोई लगता है, काम कर रहा है ना, तो बहुत खटखट खटखट पटपट होती है। इसका खत्म हो तो चलो कुछ आराम मिले। हम्म। क्या? Achat.
Good morning, sir.
Hello, Achat.
Particularly,
Hello. Good morning, sir.
Good morning. Good morning.
Very good morning, Dr. Amit.
Good morning, sir.
Please,
Yes.
Sir, please allow us to start.
please start. Please
Start the
start.
Please start.
Okay, sir. Thank you, sir.
Good morning to everyone. Namaste. It's our holy tradition to worship our goddess Ma Saraswati before any important event. So let's dedicate a prayer to Ma Saraswati. या कुंदेंतु तुषारहार धवला या शुभ्र वस्त्रावृता या वीणावर दंड मंडित करा या श्वेत पद्मासना या ब्रह्माच्युत शंकर प्रवृत्ति देवी सदा वंदिता सा म पातु सरस्वती भगवती निशेष चार्यंबा. On behalf of Rajkumar Goel Institute of Technology, Gajrabat, I welcome you all to this 5 days International Faculty Development Program on recent trends in computer science and IT in association with International Association of Professional and Fellow Engineers, USA, second Indo-UK Confederation of Science, Technology and Research Limited, London, UK. Third, International Accreditation Council for Conference and Professional Excellence, USA. While entering the year 2020, we never thought that our lives are awaiting major changes. With the coronavirus pandemic taking over our lives and the nationwide lockdown restricting mobility and changing our lifestyle. Online webinar, faculty development program, and other online conversation are becoming more important. This crisis is stressful for everyone, but it does not mean to stop learning new skills. With this ideology, we, the Rajkumar Goel Institute of Technology family, is conducting a 5 days FDP covering recent trends in computer science and IT. So I take the privilege of welcoming you all on the very first day of this online FDP initiated by Department of Computer Science, Engineering, Rajkumar Goel Institute of Technology. Now, I would like to invite Dr. Sachi Gupta ma'am, HOD CSC and Chief Convener of this FDP to present theme of the FDP. Over to you, ma'am.
A very good morning to one and all present here. Harshita ma'am, my voice is audible.
Yes, Dr. Sachi, you are audible.
Yes, ma'am. You are audible.
Okay. Honorable Chief Guest of the day, Professor Vinay Kumar Pathak Sir, Vice Chairman, AKTU Lucknow, Professor D.S. Chauhan Sir, Founder Vice Chairman, UPTU Lucknow, respected Vice Chairman Sir, Shri Akshit Goel ji, distinguished members of the Program Organizing Committee, Excellencies, ladies and gentlemen, a very warm good morning to one and all present here. It is a matter of great honor for me to welcome the day Professor Vinay Kumar Pathak Sir. Sir, your presence amidst us today provides tremendous encouragement to the department and to the organizing committee members. The presence of Honorable Professor D.S. Chauhan Sir is a matter of great honor for all of us. Thank you, sir, for being with us. A very warm welcome to our Vice Chairman, Sir, Shri Dinesh Goel ji, and I would like to express in computer science
अमित प्रॉब्लम हो रहा है क्यों साउंड का? अभी कॉलेज पे हैं आप? सर्वर रूम पे है ना? ठीक, उनको बोलो उनको। ठीक।
Hello.
Yes,
Harshita
Dakshati.
ma'am, my voice is audible?
Yes, ma'am. Audible.
Okay. I would like to express heartily welcome to our Vice Chairman, Sir, Mr. Akshay, and express my gratitude for inaugurating this International Faculty Development Program on the theme I think there is some network issue at my end. Now, I would like to welcome honorable speakers for this faculty development program. We are grateful to have 8 internationally well-known experts from abroad and from India, as well as from other countries for delivering knowledgeable talks in this international program. On behalf of CSC department, I welcome all the distinguished speakers of this program. Now, the primary goal of organizing this faculty development program is to provide research and development activities related to this theme to meet and interact with the experts working in this domain. I wish to tell you that we have received a great response for this program from 20 plus different countries, and we are having a 1921 number of entries from all over the world. Finally, I would like to specifically congratulate organizing committee for conducting this faculty development program in a wonderful manner. Looking forward for a successful program over the next 5 days, and I strongly encourage you all to become actively engaged in the various knowledge providing sessions in upcoming days. Thank you so much. Thank you.
Thank you so much, ma'am. I would now request Dr. D.R. Somashekar, sir, Director, RKGIT, to welcome all the dignitaries and speakers and participants. Over to you, sir.
Thank you very much, Arshita. Am I audible?
Yes, sir. You are audible.
Thank you once again. Good morning, ladies and gentlemen. Friends, we are highly honored and proud to inform you all that we have 2 renowned academicians and great administrators as our chief guests. For our inaugural program, Arshita, am I audible?
Yes, sir. You are audible.
Yes, thank you. For our inaugural program of International FDP on recent trends in computer science and information technology, scheduled from 13th to 17th July 2020. It is also our inform you this faculty development program collaboration with 3 international associations also. Friends, I deem this as my proud and privilege to welcome you all for the International FDP Chief Guest, Professor D.S. Chauhanji, Founder Vice Chancellor of Uttar Pradesh Technical University. Now it is known Uttarakhand Technical University, Dehradun. Our second honorable chief guest is Professor Vinay Kumar Pathak ji, Vice Chancellor, Dr. APJ Abdul.
हमसे नहीं ठीक हुआ है.
Beloved Vice Chairman, Mr. Akshat Goyal, the Group Directors, Dr. Lakshman Prasad, Dr. Dayanand Kumar Chauhan, in absence, respected all the invited speakers, delegates from India and from the affiliated
तो रात हो रहा होगा इस समय, 1 बजा हो। आमिर का लगा समझ नहीं आ रही। कोई बोल भी नहीं रहा है, समझ।
Sir, please unmute. Director, sir, please unmute.
Yes, it is unmuted.
Thank you, sir.
You made it convenient to be with us to grace the occasion. We are highly grateful to you, sirs, on behalf of the management and on my own behalf, wholeheartedly welcome you, sirs. Friends, the backbone of all our activities in the campus is none other than our respected Chairman Shri Dinesh Kumar Goyal ji and the Vice Chairman Akshat Goyal ji. Sirs, on behalf of the complete Parivar of RKGAT and on my own behalf, I wholeheartedly welcome you, sir. I also extend my warm welcome to group directors, delegates from India and abroad. My heartiest welcome to all the invited speakers of India and abroad, and my heartfelt welcome to all the faculty members of affiliated institutions and complete Parivar of RKGAT. I also extend our most affectionate welcome to all our students and friends. Friends, let me congratulate the Chief Convener and the HOD of the Computer Science Department, Dr. Sachi Gupta, and Convener of the program, Dr. Amit Singhal and Dr. Lalit Saraswat, and their team and their complete team for organizing 5 days International Faculty Development Program in association with the international organizations. Friends, the technology is advancing in exponential way, and it is inevitable to be in pace with the technology and upgrade our knowledge so that we can bring innovations, research, and effective teaching to our students. Friends, the pandemic of COVID-19 has brought a revolutionary change, making the teaching learning process more and more in digital form. Today, that is how we have get connected across the world on one common platform. Friends, you all agree with me, the latest trend of technology in the field of computer science and IT, or cloud computing, big data, data sciences, analytics of data, artificial intelligence, deep learning, fog computing, so on and so forth. I came to know all these technologies will be deliberated by the eminent professors of their respective fields. At this juncture, let me remind you all, our Honorable Prime Minister's Narendra Modi ji's slogans, Skill India, Make in India, Swachh Bharat Abhiyan, Zero Defect, Zero Effect, yes, we can, so on and so forth, could be possible only when effectively make use of such webinars. Friends, in the process of perfection, we reach excellence. Friends, let me take a quote of Swami Vivekananda. Everything that is excellent will come when this sleeping soul is aroused to self-conscious activity. Friends, in short, you are the creator of your own destiny. Wish you good luck. Once again, I wholeheartedly welcome you all for the International Faculty Development Program on recent trends in computer science and IT. I wish all the success of the program. Thank you very much. Jai Hind.
Thank
Over
you
to
so
you.
much, sir.
Thank you.
Thank you so much, sir. It's a matter of pleasure that today the founder Vice Chancellor, formerly UPTU, Professor D.S. Chauhan, sir, is also gracing the function with their valuable presence. I would now like to request Chief Guest of the Day, Professor D.S. Chauhan, sir, to give his benediction speech. Over to you, sir. DS Chauhan sir, please.
Because I and Dr. Lakshman, we were together in BHU. We were contemporary.
अमित
And
आपसे करने का
I
तो
requested him to join RKGIT.
कोई दिक्कत नहीं
Now
है
this program in RKGIT is a milestone because 5 days today for initiating any, FDP program is not a joke, and that too online, and inviting speakers and experts of the various fields. They are focusing on the subject. Nowadays, computer science become, a very focused point almost since 91 when the servers were invented. And now you can see the entire market captured by the Amazon and other, activities since 2006. And this big data, or what you call this big data, all started when this college came in the existence in 2001. People were, presenting their papers in big data mining. Even I had visited that time various, the cities, computer science departments in America, where I was for long duration and working in NASA in higher vision. And higher vision is still in computer science because even Vinay Pathak, your present Vice Chancellor, who was my student, I was his guide for his PhD. He also did work in the image processing. And various aspects of the image processing, and nowadays 3D image processing and biological various operations are taken into consideration. It has gone to a big because at that time I was working in the robotics division in the higher vision, and now it is possible because of the various development in computer science, because earlier it was not possible, but now it is possible because of the compilers and cross compilers you can use for various because this Android and high assembly language softwares, because these are all confluence in the computer science. Now every information is the history, because the day you read it, next day you will find that something new has come. So you have to be always up to date, and you have to Everest, you have to mug up, or you have to learn everything. That should the history also you have to, because people are gone, but the history is still we are taught. Similarly, in the computer science also, in knowledge become history, does mean that the up-to-date knowledge must be known to everyone. In the Indian system, the knowledge, starts from the Vedas. And Ved means knowledge. Ved means what you have to know. The teacher must know what he has to know. And he has to, acquire this knowledge from various, sources. You can have a person has got only knowledge. The person has got the deep knowledge, just like a deep learning. In computer science is a very common, what you call the connotation. So you have to learn a lot of deep things from the person who has done a lot of research. They have patents, they have a number of papers, they have attended so many seminars where he is exposed to various topics. Nowadays, when we were, appointed, or we have done PhD that time, if you have attended at least 4 or 5 conferences sufficient. But the day I had gone to America, I have seen that everybody was having average of 200 conferences. And India is lacking because now our professors, they are not, exposed to number of interactive, conferences, seminars, webinars. Listen properly. Not only tutorials you need, but a lot of listening, pouring of the knowledge also needed. Now computer science has gone just like we were teaching 4 or 5 courses 20 years before. Now if you come, there are 45 or around 50, directions of the computer science. I have guided around 56 PhD, out of that 40 in the computer science, and you can see 40 directions because I have gone to 40, that PhDs while I was guiding. I saw that the multiple, in communication, networking, image processing, even while I was in America at that time, one of the STX led by our Sarat Talk, he was Indian. He was doing consultancy only for NASA, remote sensing, the entire image processing of the entire world. And then how much, the problems in future the world is going to face, they were knowing. Even they can identify where there is a fire, outbreak, what measures they have to take, when they have to inform. Everything they were taking into account from those, image processing. Now the image processing has gone to even the biological, image processing, even the operations done by the robots. Later on, I switched over to, what you call collision avoidance in satellite, its robotics operations. So therefore, a lot of real-time algorithms for helping robots. They should identify the obstacles. They have to avoid collision, or they have to repair, the satellites. Even the Pathfinder on the Mars was also designed by our team. So we can see a lot of, infusion of various, scientists together doing work in various fields. And everywhere, one kind of the technology never works. So you have to have the knowledge, and ultimately technology has to come into the business. And now it's not a B2B, but it is a B2B, number of business on one platform. Even nowadays, the market is also planned that when you will have the 3D, image processing, the entire, the things in the market, you can just see the quality, even you can see, and you can order from there. Nothing, even you can reduce the pollution that is coming because of the vehicle movement on the road. So, a lot of things are going on in the world. But those who are researchers teaching, textbooks, the textbooks for coming generation is different, because systematic knowledge that should be, teaching the students, they must develop their capability of understanding the, what you call in sequence everything. And they should not just listen and then, yes, some perception, because human perception of the, just like nowadays, this virtual, images, then virtual real images, then perception, augmented real. So many things are coming because unless the human perception is not perfect, because human ultimately is going to take everything that is real, we have to bring this, computer science very close to the reality. The moment this whole knowledge that is, outbursting in the entire world, the student has to, he should not feel just like how to enter, because computing science and computer science that went together, without computing and without computer science, then accordingly we are designing hardwares, testing. I know that while I was working on the, this microcontrollers. Microcontrollers, they are not using any operating system. When this operating system and microcontrollers together become computer, then various programs, just like a C++ or Java, this or that, that came because they were all, tested on the hardware system. The software, hardware, then computing, then computer, then communication. Then wireless, sensor division also become prompt to, converge. And nowadays avionics. And you can see that China, almost all the apps we have, what you call disband, because the market, the confusion, disinformation, that call, that DDoS, what you call cyber security. If you just overflood or just you make, the people, they cannot get the network for their use, that is called DDoS. So, all kind of the problems are arising in this because it is completely a signal and system, computing system, then control system. So various, ways, this entire knowledge from various sources, from all the branches of the engineering coming together, and they are just finding solution in computer science. Therefore, the present day experts and inventors, they have to see that how the textbooks of the computer science, how we have to allocate them, and how to, make step by step, what you call steps for learning. So the students can come and arrive at certain, specialization and can work in the field. So the academics, then the technology in the market, and we have to converge various technologies, not one. Because just like an embedded system that brought, the smart, your mobiles, this Android brought to, various, what you call, cross compilers. You can work in one language while you can work in another language by the another compiler, that is called cross compilers. And so, the entire computer science has got changed in my, because I started in 1988 in NASA. Those things now you can see in 32 years, I'm finding difficult to, bridge my gap. 32 years I am working in this area, but still I am finding people are coming to me on various, new topics. I'm finding how much the knowledge, has gone. Even IEEE at that time when I was working over there, they were not having that much number of the journals in the field of the computer science. But you can see now the entire world, the Scopus or SCI journals, you can find infinite. Now you don't know from where it is published. So I think this FDP program does not mean that only you should know the terminology, but you have to also bother that the textbooks, how it will come, so we can teach, the immature mind. They are not capable of understanding everything. And we teachers must be very, cautious about the computing science, because without computing science, the computer science is nothing. And then second is that the signals and systems, this is also a big, big problem, because Indian system, when we have categorized all disciplines, in various way, they are incompetent to, have the knowledge of the one discipline to switch over to the another discipline. And this kind of augmentation is not done in India, while it is done in America. I have seen that community colleges, they are teaching those courses, and they can just go and find, the, what you call, the satisfaction after learning all those things. And in the market, you can have all, kind of courses available that you can listen on your, or you can just see the teacher. even you can ask that teacher on his telephone that you are speaking on this topic like this, what the meaning of that. And a lot of books are, available after frequent questions are asked by the teachers, then that they are augmented in the textbook. So my intention now, this FDP program, when you are converging the international experts, you have to request them that any book coming on this topic in your country, will let us know. And then you have to also make your library up to date, and then resource person in every institution that they can teach well that subject. So I'm very happy that RKGIT, which was my chosen institute while I was founder, vice chancellor, I was converging to this premises many times. I think in 6 years, I might have given the highest number of visits and my time to the RKGIT. If RKGIT will arise, and just pick up the academics up to date and will have the name, I will have highest satisfaction. And inaugurating of this FDP, I will request all the teachers to go deep and go wide, but bring the entire knowledge so that your students will be benefited. Because sometimes knowledge is not understandable, just like we can study Vedas, but we don't understand the Vedas are meaningless. Similarly, if you just exposed to the various conferences, but that conference will not, instill, or that will not, stimulate the faculty of perception and learning, and then the real, what you call the textbooks, and textbooks has got tutorial followed by the tutorial and the solutions and various kind of problems. Because problem solving, when you form the problem and solve the problem, and some examples are available, then students learn fast. And with this, though there are, so many areas, I know that in computer science, I am working since 32 years, but I can say that you take any one field, go in the deep, you can reach to everything. You can reach to the other field also, because there is a cross communication almost all expert, all you feel. So I have very, very much, just like a complete now data science is also become just like a very, prominent field. This cloud computing, I started while I was just joining as a vice chancellor. I was working on quantum computing, but nobody came forward to come under me. So that time I just left it. But still, I'm feeling that quantum computing will again come, and India is still lacking a lot of experts in that field. Thank you very much that you have invited me. And in this short period, what I could tell you that your FDP is very, very good, provided your teachers are excited, stimulated, and they will have perception how they have to lead their research innovations, and they can come up. Because of this COVID, period, I'm just writing a lot of to the government that the teachers are facing a lot of problem on salary, and how to make up this, that such a big teaching community should not suffer, and the country should have the best days ahead. Thank you very much.
Thank you so much, sir.
अमित इनको अक्षर जी को रिक्वेस्ट कर लो. हाँ, जब ज्वाइन करते हैं उस टाइम पे तो उनको स्टॉप.
आगे थे अब विनय को दे दो, बहुत अच्छा है, वो तो खुद ही कंप्यूटर साइंस का है।
I would now like to request Professor Vinay Kumar Pathak, Vice Chancellor, Dr. APJ Abdul Kalam Technical University, Lucknow, to kindly motivate all of us. Over to you, sir.
Okay. So, Honorable Vice Chancellor, ex-Vice Chancellor of AKTU and my Guru, Dr. Professor D.S. Chauhan sir, all other eminent academicians and all other participants. It's a really great pleasure for me to be here on this occasion of a faculty development program, which tells that what are the recent trends in the computer science. I think this program will have a long way, and this program is all of you are having. So it's a nice thing to all of you have arranged for this. I think there are simple things which will lead in computer science in the next era. One is quantum computing, which is an important part. The second is the artificial intelligence and the deep learning. I think these are very, very recent trends. If you look to the last 10 years of computing science, the computing sciences has taken a paradigm shift. People are talking about quantum computing. People are talking about the artificial intelligence. And now we have computers. There are times to come when we will see that the computer having a quantum bits as a computing thing. And all of you have heard that Google, IBM, all those are people who are uh, uh, working on this kind of an area, and everybody's claiming that they have developed or they are in the process of developing the computing science in the quantum computing. Similarly, there are a lot of tools, there are a lot of important paradigm shifts which has happened in this computings of uh, artificial intelligence. A lot of IoTs, lot of devices, lot of computer science algorithms have been developed in the deep learning, and also the deep imaging is also coming. So I feel that in these new trends of the areas, all of us have to know that what is happening and how it is happening. Uh, if the faculty development program, the new computer science people should have to have this kind of a knowledge, which is very, very important in this sense, that they have this kind of a knowledge that what is happening in the computer science. I wish a great success to the director who has pursued this kind of a FTP program. In the last also, I want to come and join when your FDP will be over. I really want to take the feedback from the faculty members, what they have learned, how much they have done in hands-on, what really this FDP has worked or it has not worked. So let me at the outset say you, all of you, a good luck to this kind of a workshop. And also I want to congratulate the team for this nice kind of a FTP program which is going to happen. Thank you very much.
Thank you so much, sir. Now, I would like to request Akshat Goyal, sir, Honorable Vice Chairman, to express sincere gratitude to Honorable Chief Guest. Over to you, sir.
First of all, it's a great moment to have a chief guest like these eminent personalities. Our Vice Chancellor AKTU, Dr. Vinay Kumar Pathak sir, and our founder Vice Chancellor for AKTU, Dr. D.S. Chauhan sir, and I congratulate all the team members of CS department and our director sir, Dr. Som Shekhar, to present this FDP with the associate with the International Association of Professional and Fellow Engineers, Indo-UK Constellation of Science and Technology and Research Limited, and International Accreditation Council and Conference and Professional Excellence USA. And the topic is really good because if you look day by day, we are going deeply into technology. So when we talk about the recent trends in computer science and IIT, we all know what are the recent trends, whether it's artificial intelligence, machine learning, IoT, and Internet of Things. There are many things, and I hope this FDP will give you the knowledge, because learning never stop in our life. Learning is a very important part of our life. You have to learn from each and everything. So at last, I give all the best to the our members, and I also welcome the eminent speakers from different nations. And at last, I will just say that I hope this FDP will be successfully gone for the 5 days. And thank you so much for everyone. And Jai and Jai Bharat.
Thank you, sir. Thank you so much. Now I would like to request Dr. Amit Singhal, convener of program, to propose vote of thanks. Over to you, sir.
Thank you, Archita. Good morning, everyone. Honorable Vice Chancellor, AKTU Lucknow, Professor Vinay Pathak, Founder Vice Chancellor, UPTU Lucknow, Professor D.S. Chauhan, sir, Honorable Chairman, sir, Sri Dinesh Goyal ji, Vice Chairman, Sri Akshat Goyal, sir, Group Director, Lakshman Prasad, sir, Director, sir, Dr. D.R. Somshekhar, Executive Director, Dr. D.K. Chauhan, sir, today's most valued invited guests, speakers, participants, ladies and gentlemen. It's a moment of great honor and privilege to have the opportunity to thank all who graced this inaugural ceremony of our international FDP with their valuable presence. I, Dr. Amit Singhal, on behalf of Department of CSE, Rajkumar Goyal Institute of Technology, and on my own behalf, extend a very hearty thanks to Honorable VC, AKTU Lucknow, and Founder VC, UPTU Lucknow, who took the time out of their busy schedule and blessed us with their kind words. We are truly humbled by their presence. I wish to express my gratitude to our Group Director, Dr. Lakshman Prasad, sir, Director, Dr. D.R. Somshekhar, sir, for providing this opportunity and support to organize this 5 days event. I am very grateful to our Executive Director, Dr. D.K. Chauhan, Dean Student Welfare, Sri H.G. Gar, and Dean Second Shift, Dr. Puneet Chand Srivastava, for giving us continuous encouragement to organize this event. I would like to thank to our esteemed speakers from various countries of the world who accept our invitation as resource person and showered us with their pearls of wisdom and knowledge. The objective of this international FDP is to introduce the participants to the recent trends in computer science and information technology and give an insight into how and where it can be used. This FDP will prove to be an eye-opening session for beginners and middle-level researchers, and also aimed at imparting the skills required to handle different tools and technologies. They are useful during the entire process of research and scholarly communications in the field of computer science and information technology. This FDP is intended to orient participants towards developing their own research plans, paying due to attention every stage of the research. More than 2,000 registrations from 22 different countries like US, UK, Sweden, Indonesia, Malaysia, Philippines, Australia, Singapore, Nepal, Ethiopia, Saudi Arabia, Kuwait, Oman, Portugal, Denmark, etc. And more than 800 colleges and universities around the globe are participating in this event. This is a huge success of the program in itself. I heartily congratulate all the participants around the globe for their active participation in this event. An event like this cannot happen overnight. The wheels start rolling weeks ago. It requires planning and a bird's eye for details. No event can take shape without a hardworking and dedicated team. It was the dedication and enthusiasm of our organizing committee which made this FDP a huge success. So I extend my big thanks to making this event successful with your contribution and research-oriented approach. Above and beyond all, let us not forget the backbone of this grand FDP. We have been fortunate enough to be backed with such a kind management of the Institute. Thank you so much for being our pillars of support. Furthermore, let us have a special recognition for all the audience who remained patient throughout this inaugural session. Let us have a big round of applause for our lovely audience. Thank you. Thank you all. Over to you, Harshita.
Thank you, sir. The theme for today's session is Basic of Wireless Sensor Data Reconstruction using Deep Neural Network. The session would be conducted by Dr. Pao and Hui. It's a great pleasure for me to introduce our speaker of today, Dr. Pao and Hui, who is going to talk us about the topic Wireless Sensor Data Reconstruction using Deep Neural Network. Dr. Pao and Huang is currently working as a professor in Department of Computer Science and Information Engineering, National Chung Cheng University, Taiwan. He is working as director in Smart Living Technology Center, CCU, Taiwan. He is also vice chancellor in Taiwan, India Artificial Intelligence Technology Innovation Research Center. Thank you.
Thank you, sir. The technical session will be started on 11:30 IST, the first session of this FDP. कौन नहीं, लेकिन वो 11:30 बजे स्टार्ट होगा ना. हेलो जी सर. जी जी सर. जी सर. जी
Hello, Dr. Amit Singhal. Can you hear me?
Yes, sir. Good morning, sir. Good morning.
Hello. So do we start now?
Just a minute, sir. Just a minute.
Yeah, sure.
So start करो. Now we are moving to our first session. Dr. Pao An Huing is currently working as a professor in Department of Computer Science and Information Engineering, National Chung Cheng University, Taiwan. He is a director in Smart Living Technology Research Center, CCU, Taiwan. He is also vice director in Taiwan Indian Artificial Intelligence Technology Innovation Research Center. He has been Director General in Intelligence Technology Department, CICT Government, Taiwan from April 2018 to December 2018. He was also Dean of International Affairs, National Chung Cheng University, Taiwan from February 2016 to July 2017. He has been part of various committees, including IET Fellow, IEEE ACM Senior Member, IICM Life Member. So without further delay, I would like to invite Dr. Pao An Huing to begin with today's session. Over to you, sir.
Okay. Thank you everyone for attending the talk. I'm very happy to be presenting our research results, which we did for the last 2 or 3 years. Thank you very much to RKGIT for the kind invitation to FDP. And my special thanks goes to Dr. Amit Singhal. Thank you for inviting me. As the presenter just mentioned, I'm currently teaching in National Chongqing University, Taiwan. I have deep collaborations with Indian universities and the companies in India. I can talk about that later on. And I'm also giving a short course online on deep learning, which will be held in August. So before that, let me just share my slide and I'll talk about the research results that we've received. Let me see how I can share my slide. Okay, can you see my slide? Let me make it full screen.
Yes, sir.
Is it full screen now or? Okay, so I think you can see the slide now. The title of the talk will be Deep Neural Network Based Data Reconstruction for Landslide Detection. This work has been conducted by one of my master students who graduated, I think, around 2 years back. The work is mainly about how we can use deep neural network models for data reconstruction in wireless sensor networks. So landslide detection is just an application. So the work is not limited to landslide detection. Actually, it can be used in any wireless sensor networks as long as we have data missing. In wireless sensor networks, it often happens that a lot of data is missing. There are lots of reasons for missing data. I'll go into that a little later on. But before that, let me say that data reconstruction basically is a big issue in wireless sensor networks. And of course, we have traditional conventional methods for doing data reconstruction, but what deep neural network models can do a better job at solving this problem. Okay, so this is the content of my talk. We'll be introducing this work, and then we'll go into the motivation. We'll also define the spatial temporal heterogeneous data reconstruction system that we proposed for data reconstruction, and then we'll go into the experiments and the conclusions. Okay, as we all know, there are lots of landslides or mudslides all around the world, especially in areas where there are lots of floodings or big rainfall, intense rainfalls. So landslides occur all around the world. And as we know that whenever there's a landslide, it is a natural disaster. So people die, there are lots of casualties, houses get damaged. This is one of the statistics, as you can see. This is for Taiwan. As you all might be knowing, Taiwan is a small island in the sea, of course. And because of the mountainous regions that we have along the center of the Taiwan island, which was called Formosa before, just in case you don't know that, but it's called Taiwan now. We have a whole region of mountains in the center of the island. The island looks like a pear, the fruit pear, and the mountain region is just along the whole length of the island. So it looks like a spine. It looks like a spine of the island. And so there are lots of mountains in the center of the island. And of course, we have lots of landslides. As you can see from here, we have average number of landslides around 11.75 per year. The number of casualties is more than 10 per year. And we have lots of houses also damaged due to the landslide. Of course, landslides might occur due to a lot of different factors, like for example, in my last talk, some participants were saying that landslides can be caused by earthquakes, by volcanic eruptions. So there are other natural disasters that also cause landslides. But here we are going to talk about how we can use sensors, data sensors, to sense the changes in the environment, including the rainfall, the soil moisture, and other factors, so that we can do landslide detection or predictions. Actually, a part of the work has been on how we can give early warnings for landslide. So I think the earliest we achieved was around 80 minutes before the landslides, but that is not a part of this work. This work is mainly about data reconstruction. Okay, so there are lots of different reasons for landslides. Basically, it's about the soil, the slope, and the rainfall. As we know that when we have a landslide, it's because the soil has a lot of water in it. It's called soil moisture. So when the soil has a lot of water, it becomes soft, and then it moves along the slope. So when the soil moves along the slope, we have mud, soil, and rocks, big stones coming down from the slope of the mountain. The reason that there are lots of water or moisture in the soil could be because of the river, but also mainly it's because of the rainfall. So rainfall is also a major factor in landslide, in the occurrence of landslide. So whenever we are trying to monitor mountainous regions for landslides, we usually design a system called cyber-physical systems. But of course, that's not only for landslide. Cyber-physical systems can be used for any kinds of systems, as long as it's like a monitoring system, a monitoring and control system for the physical environment. So in case of like the bridges, okay, bridges over the river, or the forest, or whatever. I mean, as long as it's the natural environment, and whenever we want to monitor it, we use cyber-physical systems. Of course, if it is not the natural environment, then it's like the manufacturing factories. We can also use cyber-physical systems. What exactly is a CPS? CPS is short for cyber-physical system. It's basically it basically has two parts. One is the physical system itself. So we have to know the data or the status of the physical system. So like here in this graph, we can see at the left-hand side is the physical system. So the physical system here in this case, because we are trying to detect landslides, is the mountainous region. Okay, so whichever slopes that you would like to monitor, we put sensors on the slopes to monitor the local region of whether the soil moisture has become very high, or if the rainfall is intense for a particular amount of time. So these kind of data, we use sensors to monitor the physical system. And then once we have the data, we change it into a decision system here. Like for example, here on the right-hand side, we have the cyber part. So the left-hand side is the physical part, and on the right-hand side is the cyber part. So the cyber part does all kinds of decisions, makes different decisions, does simulation, like what if something happens, etc. So that's the cyber part. So this is a general description of what exactly is a cyber physical system. As far as landslide is concerned, of course, we try to monitor the slope for soil moisture, for slope gradient, and also for rainfall intensity. And then on the right-hand side, we use a physical model of the data to check if there is a landslide. So the physical model can actually predict or estimate whether there is a landslide. So let me briefly classify the different methods that can be used for landslide occurrence. Basically, there are three kinds of methods. One is the GIS method, Geographic Information Systems. So these kind of systems store the disaster data, like the history of landslides, the geographical data. These are all based on the data in the historical past of the environment, of the landslide that have occurred. So based on the GIS, we can also do some predictions. Computational intelligence like support vector machine, Bayesian network, neural networks, random forest, genetic algorithm, these are all the different methods that can be used to predict if there is a landslide. We can also have physical models like, for example, here we have some papers which have proposed different kinds of physical models like ShellStab, SynMap, TRI, GRS, slip model, etc. So these are all different ways in which landslides could be predicted. As far as this work is concerned, we are basing the work on the ShellStab model, which is a physical model. So what exactly is a ShellStab model? A ShellStab model, with the model itself, there's a metric called factor of safety. Factor of safety means how safe the current environment is. As you can see from this graphical diagram, we have a slope here. So this represents the slope of the mountain. And then we have soil, which is in the slope. And then we have the soil moisture, the soil density, the soil depth, the soil transmissivity. So these are all the features of the soil. And then we have the rainfall here. Of course, that's the water coming from the sky. So we have the rainfall intensity. We have the period of rainfall, the length of time that the rain has is falling down on the slope. And then we also have the vegetation cover here. From this graph, we can see that whenever we have lots of rain, heavy rain or rainfall intensity which is very high for a period of time, what happens is the water from the rainfall goes into the soil. Okay, so the soil moisture increases. As the moisture in the soil increases, the force that is exerted on the slope increases. Just like, for example, if you are sitting in a chair, there's often a specification that this chair can endure at most 10 kgs, 10 kilograms. If you are going to put 20 kilograms on the chair, then one day the the chair might just get damaged, okay? Because that is not the specification, that is above the specification of the force that the chair can endure, or the weight that the chair can endure. So similarly here, the slope, based on the angle of the slope, based on the characteristics of the soil, there is always a particular amount of force that the soil can endure. If we exert an amount of force that is higher or greater than the threshold, or than the amount of force that can be endured by the slope, then what happens is the soil starts to move. Okay, so the soil starts to move from the top of the slope to the downwards. So this is called landslide. Of course, if you have vegetation cover, you are trying to grip all the soil because of the roots. As we all know, whenever we have lots of trees, the roots try to grip all the soil together, so the soil does not move that easily. And then, of course, if you have vegetation cover, it increases the threshold, okay, the amount of force that it can endure. So that's why whenever we are trying to build a new building, or we are trying to build any kind of structures on the land, we always try to check if the vegetation cover is sufficient, okay? Because if you are going to, remove all the trees, then what happens is, suppose there is big rainfall, or there is earthquake, or any kind of natural disasters, then that area could be very much in danger. So this is one of the physical model. Let me go into the mathematical formulation. As you can see here, the factor of safety is Fs in short, okay? So Fs equals, there are lots of mathematical symbols here. I'm not going to the details of the symbols. I'll just mention what is above the, what is at the top, that is the numerator of the ratio, and what is in the bottom. So here, as we can see, Fs is given as a ratio. At the top, the numerator is the amount of force that the slope can endure, okay? And in the denominator, it is the amount of force that you are exerting on the slope. So this is actually a ratio of two forces, okay? So the force that you can endure is at the top, and the force that you are actually exerting at that moment of time is in the denominator. So if this denominator is bigger than the numerator, that is, the amount of force that you are exerting is more than it can endure, which is in the numerator, then Fs becomes less than 1, okay? Because the numerator is smaller than the denominator. The amount of force that it can endure is smaller than the amount of force that you are exerting. If Fs is less than 1, then landslide occurs. So that's basically the physical model called shell stab, which uses a factor of safety, okay? So this is not something we proposed. This was proposed around 2 decades back. But anyway, this is one of the very popular model for landslide detection. I won't go into the details of all the symbols, but I'm going to just mention that out of all the different characteristics or features that is taken into consideration in this factor of safety model, there are 2 or 3 different features which change rapidly. Like, for example, the rainfall intensity. So when we have rainfall, and suppose the rainfall gets more and more intense, that is, we have a heavy rainfall, then R, the capital R here, changes drastically. The soil moisture, which is the density ratio of water to soil, this is the soil moisture, rho W over rho S. This is the soil moisture. So if the soil moisture is also changes rapidly, this is also a feature that changes rapidly. Because of the rain, the soil moisture changes. So these are the two of the different features that changes rapidly. Of course, the effective cohesion, the soil transmissivity, and the internal friction angle, the soil depth, these don't change rapidly. So normally what happens is we try to give values to these parameters or these variables in the ratio, so that those that don't change, we don't need to actually monitor them, but those that change rapidly, we need to have sensors to monitor them. So that's basically how we use IoT, Internet of Things, to monitor landslides. Okay, so the motivation is that in any kind of wireless sensor networks, like for example, in a mountainous region, you're not going to have only a single node sensor or sensor node. They're going to have multiple sensor nodes like this, okay? Then these sensor nodes, they're going to send the data through some kind of like a routing node, okay? So the black ones are the routing node, but we can also call them as coordinators. So sometimes we call them as coordinators, sometimes called routing nodes. So the sensor nodes send data to the routing nodes, and then finally they send it to some network gateway. Okay, so but in this case, wireless sensor network, a big issue is the missing of data. So data gets not transmitted to the final destination, that is the cyber physical system, don't get the data. So if data is missing, then it's dangerous because it's a safety critical application. We need to continuously monitor the mountainous region so that we know there is landslide, and so that we can evacuate the people who are staying in that region, maybe at the bottom of the mountain. We can evacuate them earlier than before the landslides have occurred. Okay, so this is a major problem of data missing. So data loss is a common issue. There are several reasons. Like for example, here we have just cited two different reasons. One is because of the finite lifetime of the deployed sensors. So sensors are working on batteries because that's the wireless sensor network. Because if it is wired, then it's not called wireless sensor network. The sensors are all wireless, so they have finite amount of charge in the batteries. So if the batteries go out of charge, then the sensors won't be able to send data. But of course, we can always try to have a system to check if the sensors are working. And then we have transmission failure. Even if the sensors are failing, are working, we still could have data transmission failure. Like for example, when landslides occur, it's because of big rainfall, heavy rainfall. So due to the heavy rain, network transmission in the air is often not working that precisely. So data does not get transferred. So there are lots of packet losses and all due to the heavy rain and other environmental conditions. Like for example, if there's heavy rain, the sensors just get washed away. Then of course something happens because the soil, the soil is all over, soil and the water are all over the sensor devices. So data transmission fails. So these are all the reasons that sometimes we have data missing. And if data is missing in critical systems, that could result in safety concerns, because then that means you're relying on these kind of systems for the safety of the humans as well as of all the equipments and whatever you have, the houses and all. So if something goes wrong with the system, then that's dangerous. There are conventional or traditional methods for doing that, for doing missing data reconstruction. Like for example, we could use relevant neighboring nodes. So suppose there are nodes that are within the neighboring regions of the sensors that have gone out of work. Then of course we could use the data of the neighboring regions to do the data reconstruction. So normally, for example, you could use the nearest neighbor data, and then we try to use, for example, linear interpolation or some kind of interpolation to reconstruct the data. But this often results in a very high error. Like for example, this is one of the work that shows RMSE. The root mean square error is 0.09 degrees in terms of temperature. And then we have another work, like for example, this is the 16th one, which shows that if you are going to use spatial data or temporal features, then it also results in a very high RMSE of 0.04. So there are different ways in which you could use different methods to reconstruct data. The conventional method is to use linear interpolation, or maybe you could use also like ARIMA if you're familiar with these kind of exponential regression methods. You could also use long short-term memory, LSTM models, which is a deep neural network model. But here in this work, we are going to use, we are going to base the work on heterogeneous data as well as spatial and temporal characteristics of the area. By heterogeneous data, we mean that often there are more than one kind of sensors in the area. Like, for example, we have rainfall sensors, we have soil moisture sensors. So we could, because these different sensors have some kind of correlation between the data of the sensors, then we could use this correlation to actually reconstruct the data, like, for example, of the soil moisture from the data of the rainfall. Okay, so if the rainfall sensor is still working, we could use the rainfall data to actually reconstruct the soil moisture data. So that's called heterogeneous data, different kinds of data. And then we could also use spatial and temporal characteristics of the area. By spatial, we mean the neighboring sensors. By temporal, we mean the past history of the particular sensor that has gone out of work. Okay, so based on the past history of the malfunction sensor, and based on the data from the nearby nodes, the current data from the nearby nodes, we could actually leverage the spatial and the temporal characteristics of the area so that we could reconstruct data. So in this method, in this work, the proposed method is called spatial temporal heterogeneous data reconstruction. So we are going to leverage on heterogeneous data as well as spatial and temporal relationships among the data. Okay, so let me go directly to the system itself. As we can see from this diagram, this is a cyber-physical system, CPS. So at the top, we have the computational elements, that is the cyber part. And then at the bottom, we have the physical entities, that's the physical part. So in the physical part, we have 4 different sensors: rainfall sensors, soil moisture sensors, slope gradient, and slope direction. These sensors send their data through the coordinator to the cyber part. Okay, so at the cyber part, basically what we are going to do is we're going to check if there is any loss, data loss. If there is a data loss, then we pre-process the data so that we do predictions. And then using the predicted data, we try to compensate for the data that has been that is lost. That is, we try to do the data reconstruction. So the basic concept here is that we do data reconstructions by predicting them. Okay, so if your predictions are accurate, then your data reconstructions are accurate. Of course, predictions, for predictions, we need historical data, we need current data of other sensors, etc. Okay, so this is a flow chart. Actually, I already mentioned this. We start with checking if there's data loss. If there's no data loss, we directly store the data. If there is data loss, then of course we need to find the missing region, record the time, do data normalization, and then apply our spatial temporal heterogeneous data estimation or any kind of estimation method, and then we try to compensate the data into the missing region. Okay, we are going to compare our work with LSTM, which is a very popular model for predictions, as long as the data is time series. So it's a time series data prediction model. By long short-term memory, we mean that within the model, actually there are different gates. Like, for example, we have the input gate, we have the forget gate, and the output gate. So the forget gate helps you to retain a part of the memory from the past and use a part of the memory from the current. So the memory cell here, CT-1, is the data from previous time slot. And CT is the data that you're going to send to the next time slot. So based on how much data you're going to use from the past data and how much data you're going to use from the current data, okay, IT, based on a weighted proportion of the data, we send the data out. Of course, there are different activation functions like uptangent and other functions here. So this is a very popular model, LSTM long short-term memory model, that has been used for time series data predictions. And this is working quite well as long as your data is simple. Okay, so this is, by simple, I mean it is only temporally correlated. Okay, so if it is temporally correlated, the data, then of course you can do a very accurate predictions of the future value of the data. But in this work, we are going to use convolutional LSTM prediction model. And by convolutional LSTM prediction, if you're familiar with deep neural network models, there are 2 popular models. One is called convolutional neural network, and the other is recurrent neural network. LSTM is actually a variant of recurrent neural network. And convolution LSTM here, it means that we are going to have a two-dimensional grid like this, and within each grid, we are going to use a convolution LSTM block to actually do the reconstruction or the prediction. Okay, so this has both, this model, convolution LSTM, has both the spatial as well as temporal characteristics. The spatial characteristic comes from the convolutional part. Okay, so convolutional, actually it works on each block. Okay, so like for example here, if there is a 5x5 grid, then we are going to use 5x5, that is 25 different convolution LSTM building blocks to actually do the prediction. So the spatial part, the spatial characteristic comes from the convolution, and the temporal characteristic comes from the LSTM block. Okay, because LSTM takes time series data. So that's why this model, convolution LSTM model, is quite suitable if you want to leverage both temporal as well as spatial characteristics. Temporal is being considered by LSTM and spatial by convolutional. I'm not going to go into the details of the mathematics here. You can look it up in any paper or on the website. This is a very popular model, convolution LSTM, but its computation is much more higher. The computation is more heavy as compared to the LSTM model. Okay, so for any kind of deep neural network models, we always have to assess what will be the network architecture, what will be the values of the hyperparameters, etc. This is the architecture that we have come up after doing lots of experiments. Like for example, here at the bottom, we have 20 by 20 by 4 data. Okay, so that means we have 4 channels here. 4 channels means, like for example, here we have soil moisture, rainfall intensity, slope, and slope direction. So these are the 4 kinds of different data that we collect through sensors at each point in the map. Okay, so in the map we have 20 by 20 sensors, that is 400 sensors, and we have 4 channels. Okay, that is 4 different kinds of data. Now the question is how you're going to construct the neural network model so that it gives a very good prediction or a very accurate prediction. Here we tried with different numbers of convolutional LSTM blocks. Finally, we came up with 23. Okay, 23. I'm going to show you the experiment results later on, but this was the final architecture. So we came up with 23 convolutional LSTM blocks and 2 layers. Because if we add a 3rd layer, we found that it does not work better, and it just increases the computation. But at the 3rd layer, we used a 3D convolution block to predict the value in the future. Okay, so this is basically the architecture that we came up for convolution LSTM prediction model, so that it could give us a very good predictions as far as the different data is concerned. Okay, so these are the numbers of filters that we used and in each different layer, and then the number of cells, etc. Okay, we tried with a different number of cells as we just mentioned, because we need to come up with an architecture that gives a very high accuracy in prediction. So we tried with 11 cells, 17 cells, 23 cells, and 29 cells. As you can see from here, the training time, of course, increases with the number of cells, because when you have a larger number of cells, the architecture is more complex. The number of parameters becomes more, the weights and the biases. That's why the training times becomes more. But the validation loss here, you can see that the lowest validation loss here is for 23 number of cells. Okay, so that's why we settled for 23 convolutional LSTM blocks, because it gives a better accuracy. That is, in terms of validation loss, it's a smaller loss. Okay, so the prediction model, this is a very typical flow chart for training and testing the model. Okay, so based on the number of filters that we have decided, the kernel size of convolution, etc., we do the randomization of the weights, and then we calculate the network error. And then based on the error, we do gradient descent. That is a very commonly used method for backpropagation, so that you could come up with a good set of weights and biases, so that the model does a good work in predicting whatever you're trying to predict. So finally, when we have a training output, we test it. So this is the test phase here. We tested with a set of data. So that is a typical flow chart of how you come up with a neural network model, deep neural network model here. We come up with a model, we train it, we test it. Okay. So of course, what we expect is that after training, we get a high accuracy. After testing, we also get a high accuracy. So there's a training accuracy, there's a testing accuracy. Okay. So that was the whole system design. Let me go into the experiments of our system, where we experiment with different data sets. So this was the experiment setup. It was performed on a server with GPU and memory. Okay, so basically what we targeted at was a grid size of 20 by 20. So there are 400 sensors, and the distance between two adjacent sensors is 2 kilometers. 2 kilometers. Okay, so it's a quite large, wide area. The data was collected from April 5, 2013 to October 12, 2017. So that's a period of more than 4 years. Okay, so we have lots of data, and these are all real data for that region. Okay, so for the training, we used 22,500 samples. For the testing, we used 2,250 samples. Okay, so that was around the testing data was around 10% of the training data. The data was collected from 7 different stations, weather stations. These are the names of the stations. These are all in Chinese. Okay, let me go directly to the map to get a better understanding of how the stations were distributed and how the sensors were distributed. As you can see from here, we have the 7 stations here. And then when we convert it into a 20 by 20 map, this is on the right-hand side, this is the map that we get for soil moisture. Of course, we have a similar map for rainfall also, but this is for soil moisture. As you can see from the legend given at the bottom, when the color is more dark, the soil moisture is lesser. And if the color is brighter or lighter, then the soil moisture is higher. So this means in this graph, at the lower left, the soil moisture is much higher than on the top right. Okay, so this is the original data distribution. Now, what we are going to do is we are going to select some of the data, remove some of the data so that they are missing, and then we try to reconstruct the data back into this map. So this is the way we try to see if our data reconstruction is good or not. For evaluating whether the predictions or the data reconstructions do they match with the original data, of course, we have to calculate the difference between the actual data and the predicted data. So Y is the actual data, the original data, and Y hat is the predicted data or the reconstructed data. So using a root mean square error, we can always check if our predictions are accurate or not. Okay, we need to have different kinds of missing data patterns so that we don't, so that this system can be used in different way, for different kinds of missing data. So we consider 3 different kinds of data missing data patterns. The first one is random. So you can see the black squares here. They are all randomly selected. And then we have gradual fading. Gradual fading corresponds to sensors that are going out of battery. So whenever sensors go out of battery, their data starts missing. Just like when your wireless mouse goes out of battery, it becomes quite unstable initially. Then, of course, finally it just goes out of work because there's no more charge in the battery. But while it is going out of battery, out of charge, the data starts fading away. That is, you get lesser and lesser amounts of data. Initially, you might get maybe, for example, 10 samples per second, and then you're going to get 8, and even less than that, because the battery is going out of charge. So this is the gradual fading here. It represents more like a temporal data error, okay, or temporal data missing. And then we also have spatial event, which is called spatial missing data. As you can see, we have on the top right, a large part of the data is missing, okay? So this happens when, for example, all your sensors were just washed away from that region because we had a big rainfall, a heavy rainfall in that region. So when we have a heavy rainfall, that part of the sensors go out of work. So in case before you can replace the sensors, or before you can replace the batteries in the sensors, your system still needs to work. Okay, so CPS system, cyber physical system, has a very important characteristic of what do you call it? Gradual degradation. Okay, gradual degradation. That means you don't want your system to fail abruptly. Okay, you don't want your system to fail abruptly. Your system can start to fail because of the sensors going out of work. Maybe the quality of the predictions or the quality of the detections downgrade, but the system cannot fail abruptly. The system has to fail gradually. Okay, so that's called gradual degradation. That's a very significant feature of all CPS systems. So in cyber physical systems, we would like the system to fail gradually, not abruptly. Okay, so that's why we have these different kinds of missing data, and that's why we do reconstruction of the data. Okay, so let me show you a visual representation of the missing data patterns. So this is the random missing data. As you can see, some of the data are missing randomly. And then we have gradual fading. You can see the black spots occurring. Initially, they were lesser, and then the number of spots increased. So that's called gradual fading. And then we also have spatial event. As you can see, a large part of the sensors in neighboring areas are missing. So that this is different from the gradual and from the random missing data patterns. So these are the three different kinds of missing data patterns that we are going to use to evaluate the CPS system that we have proposed. Okay, we are going to compare our method with linear interpolation, which is a very commonly used way of trying to fill in the missing data. So whenever you collect real data, actually you have lots of missing data. And what we normally do is we try to use linear interpolation. For example, we find that, okay, one data is, a previous data is 4 and the next data is 8. So we might assume that the data in the middle might be 6, because 4 and 8, you add it, you divide it by 2, and you get 6. So that's called linear interpolation. So you try to do linear interpolation. That's a commonly used method. We'll show you how it fails. I mean, linear interpolation is not a good choice. It might result in safety concerns, because this is a safety critical application. You cannot do that. Okay, and then of course we can use some traditional methods like ARIMA, LSTM. LSTM is a deep neural network model, but it's a very simple one. It only considers temporal characteristics. It does not consider spatial characteristics. Okay, so let me show you the evaluation of the random missing data, and then we'll go into the gradual fading, the spatial event. Those are the three kinds of missing data. And then we are going to show you how exactly the reconstructed data affects the landslide prediction itself. Okay, so initially in the first 3 experiments, we're going to talk about the missing data itself. And then we are going to talk about the reconstruction data for the landslide prediction, that is the FS value, the factor of safety value. And then we are going to evaluate the whole system. Okay, so this is the upper part of the slide. You can see that this is for the upper part is for rainfall data in millimeters. And then the lower part of the data, the lower part of the slide is for soil moisture in terms of percentage. So as you can see here, we have compared our method, convolution LSTM method, with LSTM and also with linear interpolation. You can see for linear interpolation, even if the missing rate is as low as 10% of the data, this 10% means 10% of the data is missing. So out of 400 pieces of data, it means around 40 pieces are missing. 20% means 80 pieces of data are missing. Okay, so anyway, we can see from here the RMSE, the root mean square error for linear interpolation is quite high. Okay, even for a small missing part of the missing data, like 10%, the linear interpolation gives you a very high root mean square error of 6.89 here in this. You can see 6.89 here is quite high as compared to other values. LSTM gives a much smaller error, like 0.04, but convolution LSTM gives you an even smaller error, like 0.01. Okay, so when we increase the missing rate, we can see that when we go up to 90%, linear interpolation gives you a very large error of 20.66. LSTM gives you maybe a more acceptable error like 0.17. But of course, we cannot only look at this rainfall data alone, because your safety does not depend on how accurately you can reconstruct the rainfall data alone itself. Okay, but you need to check what is the error on the final metric of safety, that is the factor of safety. So 0.17 is only on the rainfall data. And then for the random soil moisture data, you can see that linear interpolation also does not work very well. LSTM gives you a good result, but it's still not as good as the convolution LSTM. Okay, so as you can see from these two tables, convolution LSTM gives you a very small error, even if the amount of data is missing is 90%. Okay, so when we have a large amount of data missing, the error is still small when we use convolution LSTM. Okay, so this is for random missing. Now let's go on to the other missing patterns. But before that, let's see the bar charts. So from the bar charts, you can see that the pink ones are the convolution LSTM. So that's much lesser. And then that was for the rainfall. This is for the soil moisture. Okay. Okay. So let's see the result of reconstructing random missing data using the different methods. Okay. So on the left-hand side, we have the original data. Okay. The missing data is the random missing pattern here. LSTM is the result of reconstruction. We don't show the linear interpolation here because that's quite bad. So we directly show it show our results on the right-hand side compared to the LSTM model. Okay. So you can see from the right-hand side, convolution LSTM almost matches with the original model. Okay. Actually, there are some changes here you can see, but it's not that visible. And this is for 20% missing data. Okay. Of course, if it is for 80 or 90%, there will still be a difference in the convolution LSTM model here. Okay. This is for 20% missing data. Okay. So that was for random missing. And then for gradual fading, you can see the results are quite similar. I won't go into the details. You can see the results are quite similar. This is for gradual fading. Okay, so this is the bar chart. You can see the pink ones are much lesser than the other two colors. And then we have, this is for soil moisture. So that was for rainfall, this is for soil moisture. Okay, let me just go directly to the visual representation of the results. So you can see the missing, this is the gradual fading missing data pattern. LSTM gives you this one, the third one here. And the last one is the convolution LSTM result. So you can see that LSTM does quite a good job in gradual fading because LSTM itself is a time series data prediction model. And gradual fading itself is a temporally correlated missing, okay, pattern. So that's why LSTM gives you a good result. Okay, now let's go on to the spatial event. These are the numerical results of how much error we get when we reconstruct the missing data in spatial event. You can see we get similar results. This is for the spatial event. This is also for the spatial event. Okay, so when you compare it, compare our convolution LSTM model with LSTM, you can see for the spatial missing data, LSTM does not do a very good job because LSTM itself is not a spatial model. Okay, convolutional is a spatial model, but LSTM is not. So LSTM is more like a time series data prediction model. So of course, it does not do a good job in the case of spatial event. Okay, but in convolution LSTM, you can see quite matches the original method, so the error is smaller. Okay, so let me give you a summary of all the data reconstructions that we have done. So for the different missing patterns, random missing, gradual fading, and spatial event, our method gives you a very large reduction in the error. So this is the reduction in error. Okay, the percentage of how much error we have reduced as compared to LSTM. Okay, now let's go on to the actual landslide prediction. The actual landslide prediction depends on the FS values. So we need to ensure that the amount of error in the estimated FS value is small, okay, in all the three different kinds of data patterns. So this is for the random missing data pattern, the first one. You can see that for LSTM, the error in FS, that is the factor of safety, when the missing rate is 40%, it is as large as 1.23. This is not acceptable. Why? Because the threshold for deciding whether FS, from the FS value, whether there's a landslide prediction is 1. As if you can recollect from what we just presented at the start of the talk, if FS is less than 1, it means a landslide is occurring. If it is greater than or equal to 1, it means there might not be a large probability of landslide. If it is very near 1, then of course it's quite unstable. If it is 2 or 3, then it's very stable. There's no landslide. Okay, so the maximum value of Fs is 3. The maximum value of Fs is 3. The threshold is 1. Okay, so if it is less than 1, then that means landslide is going to occur. But if your error itself is more than 1, that is plus or minus 1.23, then you're not sure whether there is a landslide or not, right? So this is from here, from this result, we can see that LSTM does not work if you have more than 40% missing data. Even for 30% missing data, you can see the error is 0.82. That is very much near 1. So that is also not very acceptable. But for convolutional LSTM, like for example, 30% or 40%, you're going to get an error of 0.13 or 0.16, which might be acceptable because plus or minus 0.16, of course, it still affects the final factor of safety evaluation or the factor of safety decision of whether you're going to have a landslide, but the effect is not as large as what LSTM is having an effect on the prediction. Okay, so that was for the random missing. For the gradual fading, you can see that LSTM does a better job, but even it fails at 50%. Okay, so 1.09 is not acceptable. But for a convolutional LSTM, even for 90%, you're getting an error of 0.12 only. Okay, so this is quite good. And then for spatial event, you can see that LSTM does not work in all of the cases here. All of the 10 cases that we have tried, or 9 cases that we have tried, even for as less as 10% missing data, LSTM gives you only 1.33, gives you an error of 1.33, which is more than 1. So that's not acceptable. For convolutional LSTM, you can see it's a little larger than the previous one, but it's much lesser than that from the LSTM. Okay, so this shows that a final conclusion that we can make is that for the FS value, the factor of safety value, the root mean square error is less than 0.3. Okay, and we are going to get, and we have a very good reduction on the root mean square error of FS. So this is about FS as compared to LSTM. Okay, so for the whole system, the training time for LSTM is 3,970 seconds, and for convolutional LSTM it is 14,023. Okay, so this, of course, we need a much larger amount of training time because this is a more complex model. But this is only a one-time training, so that's fine. It's not done in real time. And for the training, we use a much larger percentage of GPU and memory. Okay. So let me just give you conclusions as to what exactly we did here. We leveraged on the heterogeneous data. We used spatial and temporal characteristics of the missing data so that we could do a very good prediction. And using the predicted data, we could do data reconstructions. And the error, even for data loss rate as high as 90%, the RMSE error is less than 0.3. So which is much better than that for LSTM. So that's the end of my talk. And basically it's about how we can use deep neural network models like convolutional LSTM for any kind of wireless sensor networks, as long as you have missing data, and if your application is concerned with both spatial characteristics as well as temporal characteristics. Okay. Finally, let me just give you a brief information on an online certification course that I'm conducting on the fundamentals of deep learning. So if you are interested in whatever I just presented regarding the LSTM models, the convolutional LSTM models, or the convolutional neural network models, or deep learning fundamentals, you're welcome to attend this online certification course, which is being done between IIT Ropar, the university or the institute that we are collaborating with currently. We have an AI center on the campus of IIT Ropar, and of course, this is in collaboration with the best marketing company. This will be conducted online. It's a 3-day course, but of course, for each day, it's only around 3 hours. So we have a 3-day course in which we are going to talk about machine learning and Python. So there will be a Python tutorial, and then we are going to talk about TensorFlow tutorial, deep neural network model construction using Python. So here we are going to build a deep neural network model from scratch. That means we are not going to use TensorFlow. We are going to directly build it. Then, of course, we are going to teach you how we're going to build the model using TensorFlow framework. And then we are going to, on the 3rd day, we are going to talk about the different tuning techniques for deep neural network models, like regularization, dropout, ADAM, RMS prop, momentum. These are all very popular optimization techniques for deep neural networks. So this is a 3-day course. You're welcome. Thank you. I can take any questions if any.
Thank you so much, sir. On behalf of Rajkumar Goyal Institute of Technology, the entire supporting team, our participant, and my own behalf, I extend a very hearty vote of thanks to Dr. Pao and Huyn for delivering an informative and thoughtful provoking talk on wireless sensor data reconstruction using deep neural network. Thank you, sir, for sharing his experience, expertise, and wisdom in delivering such an informative session. It was really a splendid presentation which exposed our participants to the wireless sensor data reconstruction. Thank you once
Thank you
again,
very
sir.
much. Thank you very much. Thank you.
Thank you, sir. Thank you so much.
Thank you so much.
Okay, thank you. Thank you.
Thank you, sir. Any query है? Query है उसमें देखना?
Thank you, audience, for your participation. Thank you. Thank you so much. For certification, please find the feedback link.